All right, everybody, we've got our systems of equations review packet. We can go through it pretty quick, but please let me know if anything is confusing and I will help you out. So first question is just asking, is this point a solution? And it's given to you as an ordered pair. So you just have to remember alphabetical order. X is 0, y is 5. And a solution means when you plug it in, you get something that's true. So let's try it. I'm going to plug in x is 0 and y is 5 to the top equation. I'm going to ask myself, does that really equal 10? Negative 3 times 0, 2 times 5, 0 plus 10 does equal 10, so we're in business. For the first equation, so we know that it's a solution to the first equation. We don't know if it's a solution to the second equation yet, so let's try the second equation. Y is 5, so that goes on the left side because y was on the left side. X is 0, so that goes right there. Then I'm going to use my PEMDAS. So I'm going to put a question mark there. 0 plus 8 happens first, because that's inside the parentheses. A quarter of 8 is 2. Multiplication happens after the parentheses. 2 plus 3 is 5. Notice that the left-hand side was 5. 5 equals 5. So we got a check mark on both equations. That means it's a solution to the system. Solution to the system means it is a solution to both equations. All right, number 2, solve it by graphing. First, I've got y equals x minus 2. That has a y-intercept of negative 2, and it's got a slope of 1. Every point along this line has a y value that is 2 less than its x value. You can double check it for yourself. Every point on that line has a y value that's 2 smaller than its x value. When I look at the other equation, it's got a y-intercept of 4 and a slope of negative 1/2. So negative 1/2 tells me to go down 1 and 2 to the right. Down 1 and 2 to the right. We can see immediately that they're going to cross over. The point that they cross over at is at the point x equals 4, y equals 2. If we wanted to, we could double check that solution, that point really is a solution, and we could double check that by trying out, does y equals 2, does that really equal 4 minus 2? See what I did? I put the 4 for x, just like in problem 1. I put the 2 for y. 2 does equal 4 minus 2. And same idea if we double check it with the other equation. 4 goes for x. Half of 4 is 2. So negative half of 4 is negative 2. Plus 4 to that, you get y equals 2. So it works for both. Moving on to number 3. Solving it using equal values method. I guess it got kind of cut off there. That's okay. Equal values method means we make the two x's equal to each other. Negative 3y minus 8, 2y plus 27. Let's get our y's on the same side. So I'm just going to add 3y. It's not the only thing you could do here. It's just one option. Then let's get our numbers on the other side. So I'm going to minus 27. That way my numbers are on one side and my letters are on the other. Then I'm going to divide by 5 to get y by itself. So negative 7 is y. I am not done until I have an x value to go with it. So I take that negative 7 and I plug it back in to either of the equations. I'll just use the bottom one. 2 times negative 7 plus 27. 2 times 7 is 14. So 2 times negative 7 is negative 14. Negative 14 plus 27 is 13. Those are my solutions. I can double check it with the other equation. Negative 3 times y. Negative 3 times negative 7 is 21. 21 minus 8 is also 13. All right. Keeping on moving. Number 4, we use the word substitution. By the way, what we called equal values on number 3 is just another example of substitution. Here, it feels a little bit more like classic substitution because I'm replacing the letter y with 2x plus 5. Sorry, with negative 2x plus 5. Notice what I'm doing is I'm taking the top equation and writing it down again, and I'm replacing the letter y with what y is equal to. In that way, I'm taking the two equations and combining them into one new equation that has both of their equations included. Distribute the negative 3. So two negatives make a positive when you multiply them. 3 times 5 is 15. Now I can combine my like terms. I have 11x minus 15 is 29. Add 15, and I get 11x is 44, is equal to 44. Divide by 11, and I get x is 4. Not quite done. I know that y was equal to negative 2x plus 5, so I make y equal to negative 2 times the number x that I found, plus 5. That's negative 8 plus 5, which is negative 3. All right, keeping on to moving. Next one up, solve using elimination. Elimination is a technique where we either add our equations together or subtract our equations from each other. So if I add these equations together, I will eliminate the letter y, because I notice that one of the equations has negative 3y and the other has positive 3y. Because they're the same but opposite signs, adding my equations will eliminate that letter. 2x plus 4x is 6x. Negative 3y plus 3y is 0. Negative 10 plus negative 20 is negative 30. Adding the equations eliminated the letter y, so I can divide by 6 and get x is negative 5. I'm not done until I get both of my variables, so I'm just going to plug in x to either one of the equations. Doesn't matter which one. I'll just use the top equation. I replaced the letter x with the number negative 5, and now you're just solving for the letter y like you've practiced many times before. Add 10 to get rid of negative 10, divide by negative 3 to get y by itself, and you get y is equal to 0. Beautiful. Okay, one more of these style of problems. Elimination with multiplication. Here's the idea. If you can add or subtract equations once, you can do it more than once as well. And so what I'm going to do is, if I subtracted these equations, I would have only 2 x's left over, and if I subtracted them again, I would be able to get rid of the x's. You can speed that process up. Instead of subtracting and adding over and over, you can multiply one of your equations first to get another equation that is just as good as the first one. So I multiplied my top equation by 2. The reason I multiplied it by 2 is to make the number of x's match up in both equations. Now, because my two equations have exactly the same number of x's, think, do I want to add them or subtract them? If I add them, I would have 8 x's and negative 1y. That didn't eliminate anything. But if I subtract them, 4 minus 4 would be 0. Be careful, I've seen a lot of students mess up here. I know that 5 plus negative 6 is negative 1, because 5 minus 6 is negative 1. But I'm not minusing 6. I'm minusing negative 6. Minusing negative 6 is the same as adding 6. So I actually get 11y here. Again, be careful with the right-hand side. I have negative 20 minus negative 20. You have something, you minus it, you end up with 0. So negative 20 minus negative 20 is 0. Dividing by 11 gives me y equals 0. I'm not done until I also find x. So I plug it into either equation. I'll just go ahead and use the top one. 3 times 0 is 0. So 2x is negative 10. Divide by 2. You got x is negative 5. Okay. All right. Just a few other questions. Sort of more conceptual thinking. If the system has no solution, the graphs of the two lines in the system are blank. So here's what it looks like when we solved by graphing and we found a solution. The lines intersect. So what would it look like if there's no solution? The lines are parallel. Okay? No solution is parallel. One solution is intersecting. So that's the answer to question 7. Number 8 talks about infinite solutions. Then the graphs in the 2 system are what? Well, how could it be infinite solutions? Well, infinite solutions is kind of like parallel. I'm going to try to draw a second line exactly on top of the first line. If the 2 equations are exactly the same, maybe they're disguised, then the 2 line graphs are going to be exactly the same, which means they intersect an infinite number of times. So for example, if one of my lines was y equals x plus 2, if one of my equations was that, and the other equation was like y minus x equals 2, I'm going to get a situation like this where one line is exactly on top of the other and they have an infinite number of solutions. Number 9, if a system has no solutions, using equal value substitution or elimination will result in an equation like blank. So if you have no solution, you end up with something that is never true. It doesn't matter what x or y you plug in, it's never true. So you will result in an equation like, 0 equals 5, or 1 equals 7, or 0.5 equals 3/4, something that is never true. However, if you have an infinite number of solutions, then you will result in an equation that is always true, like 0 equals 0, or 2/3 equals 2/3. So I'm going to pause there. Please let me know if you have any questions.